In this video, I am taking problem. So now use Newton's method or Newton-Raphson method or Broyden's method to solve the following non-linear system of equations with tolerance 5 into 10 raised to the power minus 4. So this is the error. This is the allowable error. So we should allow the error with the magnitude 5 into 10 raised to the power minus 4. Problem is x1 cube minus 2x2 minus 2 is equals to 0. X1 cube minus 5x3 square plus 7 is equals to 0, and x2 into x3 square minus 1 is equals to 0. So this is a three-dimensional problem. Solution is required x1, x2 and x3. Okay. So now if you are applying Newton's method, so this is the formula: xk plus 1 is equal to xk minus jk inverse fk, or this can be rewritten as this: delta xk is equal to minus jk inverse fk, because if you take this in the left hand side and denote this difference xk plus 1 minus xk as delta xk, so this is the formula. Okay, so this should be the formula. So now you can take this quantity in the left hand side here. So jk delta xk is equal to minus f of x. So rather than using this formula, we will use this formula. This is simple and there is no need to find out inverse. Okay. So here where xk is x1k, x2k, x3k transpose, fk is nothing but this is the first equation, second equation, third equation. These are evaluated at the point xk. And Jacobian is jk is del f1 by del x1, del f2 by del x2, del f1 by del x3. Similarly, del f2 by del x1, del f2 by del x2, del f2 by del x3, and then del f3 by del x1, del f3 by del x2, del f3 by del x3. Okay. So now what is f1? This is your f1. This is your f2. This is your f3. So f1 is this. So partially differentiate f1 with respect to x1. So we get 3x1 square. Partially differentiate this with respect to x2. So we get minus 2. So minus 2. Again partially differentiate this with respect to x3. So we get 0 because there is no x3. Similarly, this is your f2. So partially differentiate with respect to x1. So 3x1 square. With respect to x2 we get 0. With respect to x3 we get minus 10 x3. Similarly, this is your f3. So partially differentiate with respect to x1. So we get 0. With respect to x2 we get x3 square. With respect to x3 we get 2x2 x3. So this is evaluated at point xk. Okay. So now iteration number 1, put k is equal to 0. What is x naught? X naught is suppose 1 1 1. So this is our initial idea. Okay, this is our initial guess. 1 1 1. 1 1 means x1 is 1, x2 is 1 and x3 is 1. Now find out f naught. F naught is evaluated with the help of this. So just put x1, x2, x3, 1 1 1. So what we will get? 1 cube minus 2 minus 2. So we get minus 3. Similarly, from here put x1 is 1, x2 1 and x3 1. So we get 3. Similarly, here in put x2 1, x3 1. So we get 0. So this is your f naught. Similarly, j naught, with the help of this find out j naught, put x1 1, x2 1, x3 1. So what we will get? We will get this 3 minus 2 0, 3 0 minus 10, 0 1 2. Now substitute all these value herein. So we get this equation: jk is delta jk into delta xk is equal to minus fk. Put k is equal to 0. So j naught delta x naught is equal to minus f naught. What is j naught? J naught is this matrix. Multiply by delta xk, delta x naught. So delta x naught is delta x1 naught, delta x2 naught, delta x3 naught, vector quantity. So this is equal to minus f naught. F naught is this. So minus 330. So by multiplying this minus sign herein, so we get 3 minus 30. Now when you simplify this equation, so what we can do? So just multiply here and solve this system of equations. So what we will get? Delta x naught. So this is your delta x1 naught, delta x2 naught, delta x3 naught. After simplification of this equation, system of equations, with the help of any method, either simply by your calculator or you can use any elimination technique, Gauss elimination, Gauss Jordan method, any method. you can find out the solution. So this is delta xk x naught is equal to this. Now substitute this value here. Okay, so in this formula x1 is x naught plus delta x naught. This is the updation formula inspired by this xk plus 1 is equals to xk plus delta xk. Put k is equal to 0 here. So x1 is equal to x naught plus delta x naught. Substitute this value. X naught is already 111. Delta x naught is this. So just take component wise addition. So we get 1.428571. Just add 1 here. So we get 0.142857. Just add 1 here. So we get 1.428571 transpose. So this is x1. Okay. Similarly, for the second iteration, first you find out f1. So just here put these values, this x1, x2 and x3 herein and find out f1. Similarly, put these values herein and find out j1. Okay, so this is your f1 and j1. Now substitute these values in this equation. J1 delta x1 is equal to minus f1. So this is your j1. Delta x1 is this, delta x1 1, delta x2 1, delta x3 1, and minus f1. So this is your f. So this is your minus f1. Again solve this system and find out this vector, which is denoted by delta x. This is capital X1. This is your delta x1 1, delta x2 1, delta x3 1. Okay, now substitute this formula, these values in this equation and find out x2. So x2 is x1 plus delta x1. So after taking this addition, x1 is already evaluated. This is your delta x1 and this delta x1 is already evaluated here. Substitute these values here. So this is the sum. This is x2. So likewise you can compute x3, x4, x5 and so on. So all these are listed here. This is your for k is equal to 0. First iteration 1 1 1. This is our initial idea. That means this 1 1 1. X1 is this. So this is written here. This is now the next iteration. This is written here. Then this is for x3. X3 the solution is written here and x4 is written here. So you will see that up to 5 decimal places the solution is up to 4 decimal places. Sorry, up to 4 decimal places solution is same. 0.4422, 0.4422. All are same. Similarly here all are same up to 4 decimal places. That's why stop it here and this is the solution. Sorry, up to 5th decimal places. Up to 5th decimal places all the values are same. All are same. That's why stop it here. And why we have selected 5th place? This is because due to this is the allowable error. Okay, that's why. So both are same. So that's why stop it here and this is the solution. Now apply Broyden's method. In Broyden's method, first iteration is as it is same. So that's why for k is equal to 0, this is j naught, this is f naught, this is j naught inverse. J naught inverse, since j naught is this, so just find out the inverse of this matrix. So this is j naught inverse. 1 by 42 and 10 4 20 minus 6 6 30, 3 minus 3 6. This is simple calculation of a matrix. There is no, we will not use any specific computation, just simple calculation of inverse. Then x naught is 1 1 1, same values. And now we will find out delta x naught, delta x with the help of Newton's method. So delta x naught is minus j naught inverse f naught inverse. So this is j naught inverse. So this is your inverse matrix. Multiply by f naught is minus 330. So we get this value 3 by 7 minus 6 by 7, 3 by 7. That means, so this is your delta x naught. Now substitute this value in this equation. X1 is equal to x naught plus delta x naught. X naught is 1 1 1. Delta x naught we have evaluated. So this will be at 1.428571. 1.142857, 1.428571. This is basically as it is saved, as we have computed in Newton's method. So up to this stage, Newton's method is as it is same as Broyden's method. Both are same. But now the difference will occur in the second iteration. Second iteration when k is 1. F1 is evaluated as this. Delta F0 is F1 minus F0. What is F1? F1 is this. This is basically the functional evaluation at point this. We will evaluate F this at point this. So when you put x1, x2, x3 in this, so we get F1. So this is your F1. Okay. So F1 minus F0. So F1 is this minus F0. F0 is already evaluated in this. This is your F0. This is your F1. So take the difference. So we will get this value. This is delta F0. Now in Sherman-Morrison, this formula, Broyden's formula, if you will see, this was the formula. JK inverse is this formula. So here we need different terms. One is delta Fk minus 1, delta Xk minus 1 transpose, Jk minus 1 inverse, and so on so on. So all these terms is evaluated one by one here. So what we have, delta J0 inverse, delta F0. Find out this, which is this. Then delta X0 transpose, J0 inverse. So this is evaluated as this. Okay. Then delta X0 transpose, J0 inverse, delta F0. So simplify this, we get this 1.54087588. And now substitute all these values in this formula. So put k is equal to 1 here. So J1 inverse is basically J0 inverse plus delta X0 minus J0 inverse delta F0. So all these terms are basically evaluated herein. Okay. So now put k is equal to 1 in this formula. So we get this. J1 inverse is equal to J0 inverse plus delta X0 minus J0 inverse delta F0. This is bracketed here and then multiply by delta X0 transpose J0 inverse divided by delta X0 transpose J0 inverse and then delta F0. So here J0 inverse evaluated here. This is your J0 inverse. So 1 by 42. 10 4 20 minus 6 6 30 3 minus 3 6, this matrix, plus delta X0 is this vector, this is evaluated here, minus J0 inverse delta F0, J0 inverse delta F0, this is evaluated, so this is written here, so substitute it here. Then delta X0 transpose, so this is the delta X0 transpose means now column becomes row, so this is the row, and then multiply by this delta X0 transpose, and actually we have computed this complete term herein. This term is evaluated here, which is this, so written here, divided by this, and this is computed here, which is this 1.508758 written here. After simplification we get this matrix, so this is J1 inverse. Now substitute this J1 inverse in this Newton's formula, in this formula, which is basically here. In this formula, delta X2 we will find out because J inverse is evaluated. So now we will use this formula. So delta X1, because we will use this formula, xk plus 1 minus xk, we will take this quantity in the left hand side. Okay, and then J1 inverse is evaluated, so put k is equal to 0 here. So this is delta X1 is equal to minus J1 inverse F1. We have already evaluated this inverse, this matrix, multiply by F1. F1 is evaluated here. So take the product of these two matrix, this multiply by this column, so we get this column. This is your delta X1. So now find out X2. X2 is obviously X1 plus delta X1. So after simplification we get this value. Okay. Similarly for k is equal to 2, so first find out f2. F2 means f is evaluated at point x2. X2 is evaluated recently, this. So this is computed here in 0.7642, 0.3902, 0.2656. Then delta f1, evaluate delta f1. Delta f1 means f2 minus f1. F2 is evaluated here, f1 is evaluated in the previous iteration, this. So compute the difference, we get this value. Then again find out just like these values. In place of now 0 0 0, we will have 1 1 1 1. So we get J1 inverse delta F1, which is this. Then delta X1 transpose J1 inverse, which is this vector. Then delta X1 transpose J1 inverse delta F1, which is 0.361. And then we will use the formula of Broyden's updation. This, put k is equal to 1 here, sorry 2 here, put k is equal to 2 here. So we get this J2 inverse is J1 inverse plus delta x1 minus J1 inverse delta f1. This is bracketed here, then multiply delta x1 transpose J1 inverse divided by delta x1 transpose J1 inverse delta f1. Okay, substitute all these values here, so we get this matrix. This is our J2 inverse, and then delta x2 is equal to minus J2 inverse f2. So J2 inverse is this matrix, multiply by f2, this column vector, so we get this column vector. And now find out x3. X3 is x2 plus delta x2, so we will get this column 1.3551, 0.4954, 1.4117. okay, so this is the tabulation. This is for k is equal to 0, initially we have 1 1 1. This is for x1, this is for x2, this is for x3, this is x3, third row. Similarly x4, x5, x6, x7. You will see here, now up to 4 decimal places, all are same values. And so stop it here. No, this is up to 7 iteration. But still there is a need of calculations x8 x5, so that we will have solution up to 4 decimal places same, but you will see that there are lots of calculations required, so that's why we will stop it here. And you can find out x8 x9 and so on, so that finally you will reach to the desired solution. Okay, so you will do yourself. I think 8 or 9 iteration is 2 or 3 iterations are still required, so you will do yourself, and you will see that you will got the same solution after 2 or 3 more iterations. Okay, so if you compare these two, so you will see this method, Broyden's method, needs lots of calculation. That's why this is not so much popular. However, this Newton method is require less calculation, that's why this is very popular method. But but the advantage of Broyden's method is that there is no need of any inverse calculation. This method is simple for n dimension. However, if you apply this method, Newton's method, this is not so simple for n dimensional problem. Okay, and second thing is that this Broyden's method is basically is developed for computational, for computer programming. So this is simple for computer programming. However, Newton method also is simple for computer programming, but this may take little bit complex. Okay, so that's why in general, for simple calculation or for simple problems, we generally apply Newton's method rather than Broyden's method. This will need lots of calculation. Okay, this is the disadvantage of this method. So I think we have to stop here. So in the next video we will start the third unit. So this is the end of your second unit. Okay, so thank you.